Now, best part is, each lesson includes a teacher guide. It is a document designed primarily for us teachers. This guide has lesson goals, text and animation comments, question comments, question goals, and correct answers. The final part of the teacher guide contains notes which are a brief summary of the lesson. We pay extra attention to working with units in the Vividbooks textbooks. We believe that correct understanding of physical units goes hand in hand with understanding physical principles, rather than knowing how to quickly and mechanically convert units. The goal is for students to understand the use and meaning of individual units. We work with the default units from which we then compose derived units. Our default units includes both SI-based units, such as meters, seconds, but also the Newton unit, which we do not define as a derived unit because it's above the elementary school level. Additionally, students may have specific experiences with the mentioned unit. Furthermore, we place great emphasis on the meaning of physical units from the moment students first encounter them in the lesson devoted to length. Through historical context and short stories, these lessons teach students how significant it is to be able to express specific physical units, how crucial it is to use a physical unit all of us understand, and how valuable it is for a unit to be accurate and equally valid everywhere. Moreover, we focus on the fact that a derived unit results naturally together with the discovery of the relationship between the quantities. For this reason, the textbook uses a word form notation for units and gradually shortens it to finally reach a mathematical form of notation. We allow students to use their own preferred form of unit notation. When solving physics exercises, students do not necessarily need to use primary forms of units. Example, when answering questions about speed, they may use kilometers and hours. Grams and centimeter cube may be applied in the density exercises. However, it is always necessary for children to be aware of which unit will result in the solution from the units they use during the exercise. We use multiples of basic units in our textbook where it is naturally appropriate and makes sense. In short, we do not want to divert students' attention from the real meaning of the physical task by leading them to artificially have the need to mechanically transfer units. And when working with units, physical units named after important personalities, we start with units composed of primary forms. For example, with watts, we first use joules per second and afterwards introduce alternative options to students. We allow students to use both forms of unit nonetheless.